Good day to you from Chem Help ASAP. In this video, we will learn about how a machine called a mixer mill can be used to facilitate certain types of chemical reactions. The research was performed by the group of Professor Duncan Browne at Cardiff University in Wales and now located at University College London. The work was published in the Journal of Organic Chemistry. The citation is on the following slides as well as in the video description. On the top line is an SN2 reaction. The halide and a nucleophile, cyanide, are dissolved in an alcohol solvent and react in solution to form the SN2 product. This is a homogeneous reaction, and most organic reactions work this way. All the reagents react in the same phase, the solution phase. On the bottom line is the synthesis of a Grignard reagent. A halide is mixed with magnesium metal in ether. This is not a homogeneous reaction because the magnesium metal is insoluble in the ether solvent. The halide reacts at the surface of the insoluble magnesium metal at the solid-liquid interface. This is a heterogeneous reaction. Heterogeneous reactions are often slow for two reasons. First reason, the low surface area of the solid limits the rate of the reaction. Second reason, metals often have an oxide coating that inhibits the reaction. How can we fix these problems in heterogeneous reactions, particularly in making organometallic reagents? We can use something called a mixer mill. Here is a diagram of a mixer mill. It's also called a ball mill. The mill consists of a stainless steel jar with one or more steel grinding balls. Place your reagents and desired solvent into the jar. The jar and its contents are then mounted into a mill which shakes the jar. The grinding ball pulverizes the solid reagents and both exposes fresh reactive surfaces and increases the solid surface area. The result is a heterogeneous reaction that occurs with a faster rate. The use of mixer mills falls within a branch of chemistry called mechanochemistry, in which mechanical action, like a mixer mill, can improve a reaction's outcome. Let's see how the Browne group used a mixer mill in a reaction. Here is the reaction. It's called a Barbier reaction. It is a heterogeneous reaction, much like a Grignard. An insoluble metal, zinc, reacts with a halide to form an organometallic reagent, an organozinc reagent. In Barbier reactions, the organometallic forms in the presence of an electrophile and immediately reacts to give a tetrahedral intermediate shown in the bottom left. The exact mechanism of this reaction is perhaps debatable. In the last step, we'll add acid and water to protonate our alkoxide and form the alcohol product. The reaction shown has a yield of 81%. Yields are generally high across a range of aldehydes and ketones and even some imines. Through use of a mixer mill, the Browne group could complete the reactions within 2 hours. In conclusion, heterogeneous reactions often benefit from additional tools, like mixer mills, to facilitate the reaction. If you are interested in learning more about the work of the Browne group and aspects of mechanochemistry, then check out the reference on this slide or in the video description. Please subscribe, like, or leave a comment. Take care.